Hello, ladies and gentlemen. Today we are going to continue in chapter 12, and we are going to work on volumes of prisms and cylinders. We are actually going to switch gears to volume and work through volumes of the solids that we've already calculated surface area for. And the good news is volume is actually easier to calculate, and it's pretty straightforward. So when we look at the volume, we're looking at what fits inside. Surface area is what would cover the outside surfaces all added together. Volume is what's inside. So we look at the number of cubic units that make up the inside or make up a solid. And this Rubik's Cube is a great example because we can see that there are 9 cubes on this bottom layer. And then we have 3 rows of cubes. So we have 9 on the base, and we have 3 rows. So we have 9 times 3, we have 27 unit cubes that make this up. So really, that's all there is to volume, is no matter what shape the base is, you're going to calculate the area of that base, because that's going to give you how many unit cubes fit on that bottom layer. So that we're going to use capital B to stand for the area of the base. And then we're going to multiply that always by the number of rows, which is the height. So we have area of the base times the height, and that's how simple it is. Now, it doesn't matter what shape your base is. You just have to use a different formula for the area of that shaped base. So, volume of a solid is the number of cubic units contained in its interior. Volume is measured in units cubed. So lots of real-life examples of volume and surface area. And sometime in your life, somewhere down the road, you will be calculating the volume or surface area of something, probably for some home project that you'll do. Right now, I know it's probably not that interesting to you, or you might not think you'll need it, but I pretty much guarantee that you will eventually calculate that. So we started with volume of a cube, and we have sort of this special formula of side cubed, because when we look at volume as the area of the base times the height, since the base is a square, we're multiplying the side times the side. And since the height is the same length or dimension, we have side times side times side, or side cubed. You usually don't need that specialized formula unless you're given the volume and you want to work backwards to find the side length. So if we look at the volume of this cube, we take the area of the base, 2 times 2, times the height, 2, or 2 cubed, which is 8 feet cubed. Here's an example where I told you where we would work backwards. So if we know the volume of a cube is 60, we'll put the 60 in and solve. And so we're looking for what number times itself 3 times would give us 60. Well, to find that, what we're going to do is take the the cube root of each side. And on your calculator, your graphing calculator, you're going to find that cube root under your math button. And if you scroll down, you'll see the cube root. So if I take the cube root of 60, what that gives me is, it gives me that my side length is approximately 3.91 yards. Okay, so prism. Every base in a prism is a different shape, potentially. So this is why we have a pretty generic formula where we're just calculating the area of the base times the height. No matter what shape base is, you plug in a different formula for that capital B. So this particular example, the shape of your base is a rectangle. So when we look at volume is the area of the base times the height, the base area is now lowercase b for base times the height. And then we have another height of the actual prism. So this is where it can get a little confusing. So I'm going to take 5 times 6, that's the area of the base, times the height, which is 8. So when we multiply those numbers together, we just get 240 units cubed. All right, moving on. So now, sometimes these figures get tricky. A lot of people want to go, oh, here's the base. But no, this is a prism. So everything except the base and its parallel counterpart have to be rectangular or quadrilateral faces. And this right here is not. So this is not resting on its base. Okay, so that rectangle on the bottom is not the base. What is the base is this triangle right here. Okay, so we have the volume is the area of the base times the height, and since our base is a triangle, we have 1/2 the base times the height, and then times another height. So make sure you're not mixing up which height is which. Okay, so we have 1/2 the base, which is 4, times the height of the triangle, which is 10, and then we multiply that by the height of the actual prism right there, which is 2. So now we get a grand total for our volume of 40 centimeters cubed. This is a trapezoid. Okay, so now our volume is the area of the base times the height. Since our base is a trapezoid, that is our formula of 1/2 base 1 plus base 2 times the height. That's the area of the base. Then we multiply that by the height of the actual prism. So here is the height of the actual prism. That goes in there. So now we can plug in all the rest of the numbers. We have our bases, our 6 and 9, and the height of our trapezoid is actually 7. So again, we're just multiplying all these numbers together, and you should get 210 inches cubed. Here's where we get into the ones that make it more challenging, and I noticed from some of your homework that people were struggling with solving these regular polygon shapes. Okay, we can see all of these are marked the same, so we know this is a regular polygon. So again, I start out by writing area of the base times the height. My base is a regular polygon, so I have to use 1/2 the apothem times the perimeter, then times the height. So do I know the apothem? No. Do I know the perimeter? Yes. So I'm looking for the apothem, but I know the perimeter is 8 times, we have 1, 2, 3, 4, 5, 6. So 6 times 8, our perimeter is 48. So now I need the apothem. Okay, so how do I find that apothem? Well, remember, in a regular polygon, it's made up of all these congruent isosceles triangles. And when we take 360 and we divide it by the number of triangles or angles, we get 60. So this is 60 degrees. So now, when I drop down this apothem that I'm trying to find right here, I have this triangle. Here's my A, this is 30 degrees, and this is 1/2 of 8 or 4. So now, since this is a 30, 60, 90, I don't need to use trig. I can use the fact that this short side is x, and the hypotenuse is 2x, and the long side is x root 3. So that means my apothem is 4 root 3. So I take the area of the base. Now I'm going to multiply by the height, and the height is 5. And again, multiplying all this together, we could actually get it in, an exact answer of 480 square root of 3, but most of you are probably just going to use your calculator, which is totally fine. Round to the nearest hundredth, and there you go. All right. So here we're working backwards to find the missing height when we know the volume right here. So our volume right here is area of the base times the height. And so I'm going to put 360 in for the volume. And my base is a triangle right here. So my base is 1/2 the base of the triangle times the height of the triangle times the height. That's what I'm trying to find. That's my x. So the base of my triangle, okay, this is the base of my triangle, and this is the height of my triangle. Okay, I don't have the base of my triangle right now, but I can find that base right there. I can find this base by using the Pythagorean theorem, because this is 17, this is also 17, because remember the bases are parallel and congruent. So I can use the Pythagorean theorem, and 17 squared minus 8 squared is going to give me my base squared. So that means that my base is going to be 15. So now I have that 360 is equal to 1/2 the base times the height, which is the height of my actual is 8 of the triangle, and then I multiply that by x because that's the height I'm trying to find. So continuing to simplify, 360 equals 60x. Divide each side and we get x equals 60 feet. And it does not look like this is proportional in this problem as far as what it visually looks like, but that would be your answer. So now we move into volume of cylinder. The volume of a cylinder, again, is just the area of the base right here times the height. Well, it just so happens that our base is always going to be a circle. So we really could memorize this specialized formula, but again, you already know area of circles, so you can just do pi r squared times the height. That's your area of the base times the height. And my radius here is 7, so I have pi times 7 squared times my height, which is 2. So again, if I wanted to get an exact answer, this would be 98 pi, or approximately 307.88 centimeters cubed. And even if you're going to leave it as 98 pi, you need to include your units cubed on there. And here's one where we work backwards with volume of a cylinder. So volume is the area of the base times the height, and we know our base is pi r squared times our height, and it tells us the volume is 3600 pi. So to solve this for h, what I'm going to do is, not solving for h, sorry, I'm actually solving for my radius because I was given my height. My height is 16. And you could draw a picture, sometimes that makes it a little bit easier to do, but not necessary. So now I'm going to divide each side by 16 pi because that will cancel those out. And so now I get r squared is equal to 225. Take the square root of each side, and r is equal to 25 centimeters. So there is something called Cavalier's principle, and basically it says if two solids have the same height and same cross-sectional area at every level, then they're going to have the same volume. And so really what this guarantees is that if we have a cylinder that is not, or prism, that is not right, we can still calculate the volume the same way. So if we were going to calculate the volume here, we would do the same thing we've been doing because Cavalier's principle guarantees that it will have the same volume. It's kind of like a deck of cards. If you slide the deck of cards, you haven't changed the volume. It's just not at a right angle anymore. So for this particular example, the area of the base is pi times my radius squared times the height, which is 5. And that gives me 20 pi inches cubed. And you could get a decimal for that if you prefer. All right. Also, last thing here. If you have multiple solids, okay, you can add the solids together. So you can find the volume of this particular solid by simply finding the volume of like this solid right here, and then adding it with the volume of like this whole thing right here. And I would find that whole volume by taking the large one and subtracting out that little piece right there. So that's just the volume addition postulate. It kind of makes sense, I think, that the volume of a solid is the sum of the volumes of all of its non-overlapping parts. When we did surface area of multiple shapes put together, we sometimes had to subtract out some of the surfaces that were sort of common and joined together, like in this case here, but we don't need to worry about that with volume. So give yourself a chance to work through some problems here. I'm letting you decide how many problems you need to do, which ones, but try a variety of problems so that you're prepared for the test, because that'll be your last assessment in Chapter 12. You can take advantage of my office hours by messaging or emailing me, and I also will be having another Zoom this week, so you can ask some questions live if you prefer. Have a great